This is Senior IT Programming. This programming lesson will cover C++, Java, and Objective-C. Most books are top-down, which makes it hard for high school students. Most of these books are top-down because they're meant for university students or people with programming experience. And top-down books are object-oriented books. I want to teach you programming from bottom up, and this is called procedural programming. And this is typical of older languages such as BASIC and scripting languages. The problem with top-down is it's like trying to teach you advanced calculus before you've even learned algebra. Now, why do you want to learn programming? It's great as a career, but more importantly, it'll teach you problem solving, organization, writing explicit instructions in the correct order, expanding your working memory, and improving your math. You can do all of this, but you must persist. You have to struggle through the exercises to learn. A basic component of computers is memory. And there's two things that go into memory: data and code. Together, you call that a program. And data is the plural of datum. Code and data can be mixed in memory, but most languages will separate out the code and data. Most operating systems are multitasking, and to ensure security, the OS will typically give you a chunk of memory and forbid you to access outside of this chunk of memory. Each piece of code and each piece of data will be put in its own memory location or address. And where it goes is highly dependent on the compiler and linker. If you have global data, it generally has a fixed memory location for the life of the program. And code almost never moves in memory while executing. Generally, the exception to this is obfuscating the code, which means to hide the code from other people to look at. And this is code to protect the program from being copied or to look at what the program is doing. Now, the essence of any program is to manipulate data using some logic. So what does this look like? We calculate some values, we store them, or we send them to the OS to be outputted on some hardware or interface device. If you're working with old computers, you can just go to the hardware directly without going through the OS. But security is important, and the new OSs generally don't allow that. Now, more complicated programs really just have more code, logic, and data. So if you learn the basics well, you can create complicated programs. Now, in the beginning, you will be exposed to some advanced code, and that's just to get the programs working. So just use it and be aware that we'll explain it later on. Okay, so chapter 1, we want to print and use some simple functions. Most programs will display some kind of information, and usually it'll be text or graphics. Especially in games, it'll be graphics. So let's start with displaying text. Displaying text can show you some calculated information, or it could just let you know where you are in the program and show you the order in how it's executing. This is important because the code might not be running in the order that you expect. Now, for all assignments, you need to put your name, assignment, and the date. And this is a sample. We start comments with // and that means that this is not a piece of code, it's just comments for people to read. So let's look at the first exercise. It's hello. In C++, we have two ways of outputting text. One is with cout, and the other is with printf. Cout is C++, whereas printf is plain C. And anything we want to output literally is surrounded by double quotes. So let's run this project. And it prints hello world, and prints hello world on a new line. And that's a simple program. So all it does is print whatever we type up. So your exercise is to modify that example and just print your name, and you replace this with your name, is now programming. Okay, so that wasn't too complicated. If you use escape code, it makes your printout a little bit nicer. And we need these escape codes in order to print stuff like backslash and quotes. So let's look at an example. Demo of escape code. /n means a new line. And /t means tab. And let's run this. So as you can see, a tab will bring it up to the next multiple of 8 column. So tabs every 8 characters. If you want a quote, single quote, you can just use a single quote. You can also use backslash single quote. But in order to get a double quote, you have to put a backslash and a double quote. Otherwise, it won't show up. These are the main escape codes that you'll need. There are others. If you load up the PDF for this chapter, you can click on these links to see the escape codes. And generally, if you're printing out tables, you want to use these tabs to generate your column format. For your exercise, you'll need to generate this. I'm not asking you to do math. Just print these numbers out literally. So use quotes on your lines. These simple functions don't take any parameters and don't return any parameters, but they can make doing repetitive tasks easier with fewer errors. Let's look at an example. So pattern 1 is a function that prints out a whole bunch of asterisks. Pattern 2 is a function that prints out a dash, a space, dash, space, and so on. Pattern 3 prints out space, O, and so on. So the main function prints pattern 1, pattern 3, pattern 2, pattern 1, and so on. So let's run this. So here we go. It's much better to do this than to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 printfs, because this is more maintainable. For instance, if I wanted to print some more dashes and I wanted to print some more O's, and now I run it, you can see that it's done that for every case. So your exercise is to use some simple functions, and you'll need 2 to print out this diagram. Now, exercise 4, I'm going to let you use your judgment. You come up with any solution necessary to do this figure. And when you've done all your exercises, come and get me and I'll look at your code. This completes the overall lesson. You'll need to go to the Java video or the Objective-C video to learn about your specific language.